The second presentation is from Preeti, Sharma and Parvinder Singh from Synopsys, and the title of the presentation is Issues with Integrating Customer TLM IPs. Use Synopsys IP Validator. So over to you, Preeti.
Hello everyone, my name is Preeti Sharma. And
repeat, sorry Preeti, one more time that the polling would be reflecting on your screen. So kindly do the polling on innovation, quality, presentation, and the positioning. Thank you. Yes, Preeti.
Hello everyone, my name is Preeti Sharma and I am working as an R&D manager in Synopsys India. Today I will be talking about the Synopsys IP Validator, where we have created this innovative flow to resolve all issues with integrating customer complex TLM IPs. Now let me quickly go over the agenda. First, I will talk about the background and motivation for creating this flow. Then I will be talking about the Synopsys IP Validator, giving the overview and all the working details. Then I will be covering the results, future work, and in the end, I will summarize. Before I start with the flow, let me give a brief background into the domain where we work in. So I come from the automotive domain, where most of you would know that automotive is all about autonomous or self-driving cars, which are the future. Now these cover very complex functionalities such as image recognition, vehicle control, connected vehicle sensors, AI, infotainment, you name it, and they all have it. Now, majority semiconductor companies across the world are delivering highly trusted embedded designs, including ADAS, communication gateway, cockpit, and instrument cluster solutions. Now, of course, with such high complexity of the SoC comes the challenge of drastically increasing software complexity as well, because embedded platforms and associated products are getting smarter and development cycles are shrinking. Now here my domain comes into picture, which is virtual prototyping, where we kind of encourage the customer to use the efficient shift left parallelization in the automotive development chain, which not only helps in acceleration of the development of SoC, but also of the associated software. And in this process, there are hundreds and thousands of complex TLM IPs which are developed and assembled. Now, of course, these IPs can either be developed internally or can be provided by the SoC vendors as well. Now, focusing more on the TLM IP, the overall turnaround time of integrating any customer TLM IP can be really high, because it is directly proportional to how qualified the IP model package is shared by the vendor. And we have seen with experience that almost as high as 50% of the IPs can come from the SoC vendor. Hence, the quality of the IP becomes very important, considering the shrinking timelines and the high development timeline pressure on all the sides. So now let me talk about the shift left that I just talked about previously. And here you can see that typically, traditionally, there is a sequential way of first the SoC development, where it is the hardware prototype board that gets developed, which contains the SoC, and then the software development happens. Now, the idea here is to shift left the software development so that it overlaps with the SoC development timelines. This means that the software is in a much further advanced state when the hardware prototype appears. This saves a lot of development time and, of course, is fully parallelized and allows for testing to also be front-loaded. With this overall methodology, we have seen customer experiences where virtual prototypes, or in short VPs, they enable a lot of cohesiveness in both hardware and software development and integration in parallel, leading to early identification of hardware-software issues, minimizing any untested integration issues for hardware-software, and also enabling software fault testing. Customer can definitely also run these software regressions in the OEM cloud. Now, the target here we see is eventually the pre-silicon software development for the SoC vendor, and in the SoC vendor in the form of device driver and all the software development or acceleration of the basic software package for these customers. Now, what is a VDK? Well, if we put it simply, it is just a fast software model of the digital hardware ECU or SoC, just abstracted enough to run unmodified binary production software. Its purpose is about software execution and not about the hardware behavior, which means that we simply model enough to convince the software that it is running on an equivalent hardware board. So if we look at the overall product breakdown here, you can see that a VDK is typically at the ECU or the MCU boundary, and a VDK creation tools are basically used to build models and connect them up, finally representing a unit of simulation. Now here the specification part becomes very important because this is something that we receive from the SoC vendor. We read the specification, we also get some IPs from them, and overall how the process of integrating these TLM IP happens in the virtual prototype SoC. Okay, so coming back to the motivation of the IP validator, so definitely the first reason is the complexity of the TLM IP. The TLM IP is complex. It's a complex vendor model. It is also a black box for Synopsys, and it has a lot of quality issues at multiple stages like functional, compilation, documentation, packaging, etc. And different teams within the vendor's environment, they have a different working setup and validation environment, and it is difficult to align that with our working setup. Then it is also difficult to particularly enforce a vendor to ensure highest quality of TLM IPs. It can be sensitive and challenging at times, mainly because of language barriers, different geographical setup, and of course, delivery timeline pressures on all these sides. At times, we have seen it took us months to just align with them on fixing some of the issues with their packages, which were working at their end, but not working at our end, and making them understand the challenges. So it is really time consuming. Hence, it is really important that certain crucial guidelines, they are defined to make sure that the TLM IP is well qualified for the VP SoC. And what could be a better way other than automating this whole process and removing all human error-prone efforts? Now, this brings me to the next slide of the flow itself, the Synopsys IP validator. Now here you can see that the left-hand side shows kind of an image of the IP validator overview. This is also a quality parameter for us where detailed IP checking is happening. The first stage of the validator flow is the checking of the packages. What this means is that exhaustive validation happens on the vendor IP packages and multiple quality parameters are checked. Vendors can also define their own rules. I will come to that in a while. The flow is also very interactive, where it gives suggestions to the vendor for fixing of issues, and there are certain customizations which are possible, and it involves no manual unpacking or checking of the package contents. The second step is the quality report generation, which completes within seconds, and it generates a detailed analysis log, which acts as a quality improvement guide, which are simple text files. And these files, they also categorize the issues and prioritize those in errors, warnings, etc. And the third part is sharing this overall package, the detailed logs and the overall setup with the customer or with the VDK users or SoC vendors. And it is very easy to share and collaborate, ensuring high level of productivity and independence on all sides. And of course, really meaningful and cordial alignment leading to customer trust in the longer run because of minimal involvement of human intervention and errors. Let me go into a bit more details of how does this IP validator work. So the main requirements here are that there are certain inputs which are given to the validator. First is the IP specification documents of the vendor IP that are passed on to it. Then it is the IP compilation setup and the IP source code. All this is combined, it goes to the validator flow, and what it generates is the analysis report. Along with the analysis report, it also generates a configuration.txt file. Now, this is an important piece of the flow because it is the file that actually enables the feedback loop for the vendor to customize the flow, to define their own rules, to modify, to add, to remove these checks, and to make sure that if there are any deviations that the flow is capturing, which is not aligned with their expectations, they can make certain customizations at their end for future usage. Now extending it further, what happens next? At the VDK author end, that again the IP documentation is passed to the validator flow along with the source code, and you can see that the configuration.txt file also gets passed, which is the updated vendor guidelines. So it is really a combination of the guidelines that we define plus the guidelines that the vendor can define. Everything gets passed on to it, and eventually it returns a validated TLM IP. Hence, this flow really takes care of all the missing information in the IP package, all the issues which are there in the IP package that Synopsys needs to get fixed by the vendor. So if there are any changes as well in the package or in the overall guidelines at the vendor end, all that is also taken care of by the flow here. So you can see that it is not just a one-sided flow, it is both an interactive and two-way flow where inputs from us and from the vendors are taken together for a seamless solution for all of us. Now, in the end, of course, the summary report is prepared for the validated TLM IP. It contains all the issues, missing information, validator logs, and it again packages all the contents and automatically creates a zip file, which is ready to be sent to the vendor. Covering few more details on the IP validator side. So on the left hand side, you can see it is a typical any TLM IP package that comes from the vendor. It comprises of a README file, which tells us how to read the package. Then it consists of certain specifications of the IP, then the compilation environment, which is typically a makefile, the source code, and the third-party libraries that can be used for, say, compilation or simulation run of the TLM IP. Now, there are also prerequisites that the validator requires because this is a complete Python-based flow. So the required version of the Python is needed. And there are certain additional packages which are needed. For example, pretty table, XLRD, pandas, because there is a lot of data crunching that is done at the backend in terms of reading the Excel sheets, reading the makefile, and just making sure everything works out of the box. Now, the modular output, which is being generated by the IP validator, is really worth it because it generates very simple verification reports in a text file format, which tells you the pass and fail criteria and the reasons. As I already talked about, it also generates a configuration text file and a detailed flow compilation log as well with various repository options that user can choose and control. I will now next show you the results of this overall IP validator to give you a sneak peek into the logs. The first you can see is an analysis report for the specifications verification of the TLM IP. You can see that there is a command that we are passing on the command shell prompt, and then there would be a message of the configuration file generation because there is a default config file that the flow automatically generates from the existing setup. Then the verification has started. Then there are certain details of the IP, which the flow is verifying. And in the end, you will see there is a verification summary where it talks about the percentage of passing test along with a number of error as well, which it reported. The next step in this flow is the verification of the IP compilation, where it starts the compilation. There are certain hash defines or the environment which the flow would be needing, which it automatically picks from the makefile setup, and it prints all those messages and variables here. And in the end, it once the compilation is complete, it just prints the status, whether it passed or failed, and generates a final completion message. This snapshot is really important because it is talking about the interactive user actions, which I highlighted previously. Here you can see that whenever the flow is running and there is an error which the flow is reporting, it also asks the user that do you want to fix it? And I'll give you an example. Here the flow did not find a specific file, it was looking for validation, which was defined as one of the check. Now, after this file was not found, it actually asked the user that, do you want to change the directory name? And user says yes, and user provides the updated directory name, and that again checks, and then the flow completely then verifies it successfully. So this is again kind of a feedback loop that goes back to the flow, and it then updates the path at the backend as well, so that in future this updated path gets picked up. This is the detailed summary report of the overall analysis of the validator flow that is important for the SOC vendor. So it comprises of the summary results of the specification checking, which we showed earlier, and the compilation check, which tells that the model compilation passed. In terms of quality metrics, you can see that this also comprises of the detailed checks, that when we say that, say, a particular 95.24% of test passed, what exactly did that mean? It takes into the category that was it related to some command, some interface ports, or some, say, specification. It details out each and every check and shows the status here in the result column. Now, since we see that there was one check which got failed, it also highlights it here, and in the end you will see it would also show a reason that why this particular check failed, because there was something missing from the vendor IP package documentation, and there was some column whose entry was missing. So this is kind of a really good input for the vendor to go back and fix this package and reshare it with us. So that is all about the flow. Now, of course, this is not the end of the road. There are a lot of things that we plan to do in future. One is that we are also looking at doing some auto fix of the identified issues as well in the TLM IP packages. What this means is that we just don't want to highlight the issue, we also want to fix it. And we just unpack the IP, fix the issue, pack it back, qualify it again, and share it with the customer. The second is that we are also looking for a completely end-to-end automated setup. Today, it is just the validator, which is automated. But once the flow completes, we have to combine some of the reports, and we have to manually send an email to the vendor. But we also want to automate this in future. The next one is we're also looking at providing a basic UI as well for better user interactions, because this is an interactive flow, and switch it from a pure command flow to a UI flow. And this is kind of a complete future vision we are looking at, where we want to plug in this flow into our tools as well, because the vendors, they use our tool to complete the SOC, to integrate the TLM IP themselves. And we just want to give them a play button where it not only checks the IP, but it also integrates in the SOC automatically using our tool. To summarize, I would highlight that from where we started, the SOC vendor, what they wanted really faster ways for us and for them to integrate their TLM IPs in the virtual prototype SOC. And they were also looking at a quick turnaround time in reporting and fixing any issues in the TLM IPs. What we really provided a highly innovative and interactive validator flow, which seamlessly guides the vendor on the IP quality issues and tells them that how they can fix it. And the solution and the flow is highly modular, and it is very easy to understand, because the reports are very simple, and with all the detailed verbosity, the vendor can easily understand the challenges, the issues, and how they can fix it. And of course, very efficient sharing and customization of updated IP packages across teams, and vendors can tweak the overall flow based on their requirement, and can add more checks and guidelines to it using the customization feature. Now, the icing on the cake, the real result that we got with the SOC vendor in this is that today there are multiple SOC vendors and internal teams in them who are using this flow, and it is across 100 people who are efficiently using this flow today. When we started around 2.5 years ago on this flow, it were the TLM IPs that we used to receive from the vendor, they were really bad quality, not more than 30% qualified. But after using this, the flow really pinpoints the issues. It has also made the vendor learn in the process. And today, the IPs are qualified as much as up to 95%. Then there is also a significant reduction in the overall validation time for the TLM IP. Earlier, we had to do a lot of manual efforts and discussions and iterations and explaining them the challenges. And it used to take around 4 weeks, but now this has been reduced to just 5 minutes. And all in all, if I talk about the end-to-end solution, this is now a completely automated collaboration. So this means that there have been reduced meetings and discussions overhead, easier sharing of packages and contents, easier explanation, and no scope of manual errors. So this has eventually saved around 70x times on both the sides, which is really, really a good feat for us. And the vendor is really happy. The VDK users are really happy, and they all are using it to our advantage. And this has significantly helped us and them in reducing the timeline pressures and deliver high quality SOC platforms for the end customers. That's all I have from my side. Thank you for your time. Now I can open up for any questions that you may have.
Thank you, Preeti, for the interesting presentation. Good to see the improvement. I have a few questions. Let me read it out to you. So the first question is the IP spec that you mentioned that goes as an input to the IP validator. What is the level of details that are captured in this IP specification?
Okay. So the IP specification document can be as detailed as possible. Typically, we cover 3 categories into it. One is the interface information, where it talks about the overall interface, input, output ports, their types, their categories, all these things. The second part is mainly about some of the, say, register information, internal functionality, some of the major functions that it would be using in the code. And the third category is about the commands that the IP would be supporting. So there are certain commands that the user can invoke from external world, and all those commands need to be supported. So it is just like a framework overall that we cover, and all these are provided in the specification document. Of course, the flow is highly customizable. So if there are more additions, if some IP vendor wants to do in the specification document, we also cater to that, and we can cover more additional checks based on what more details they have provided in the specifications.
So it's easy to plug and play and
Yes.
customize it.
Yes,
More
that's
information
true.
needs to be added for specific use case scenarios and so on.
That's correct. Yeah.
Okay. Okay. I have another question, a follow-up question. Can IP validator be used on standard system TLM models or any models authored using a specific? I mean, is it only, sorry, the question is it only for models that are authored using a specific modeling authoring tool, or can IP validator be used for standard system TLM models as well?
Okay. Yeah. So that's a good question. Thanks, Pankaj. And yes, it is actually valid for any system C model tool. It is a very generic solution. We allow to take in any system C IP, even if it is say OSCE compliant, and it is not dependent on any particular authorized tool. Of course, we integrate it in our environment so that it can work with our tool, but it can come from anywhere. Any basic standard TLM system C or TLM2 IP, we'll just take it up, and this will work out of the box.
We still have some time, so I'll ask one more question.
Sure.
How does this interactive flow work with the vendor? How does the automation that you shared, you already mentioned about it, but if you can elaborate a little bit more, how does the automation help here?
Sure, Pankaj. So yeah, that is the kind of one of the important pieces of the flow, the interaction and the overall feedback loop that we provide. So there are 2 parts to it. One is that whenever any SOC vendor or a VDK user is running the flow, there is a default configuration.txt file that gets generated that I talked about, and it contains the default setup, the default environment, any directory structure or file names or path that the vendor has provided to us. Now, this configuration.txt file also goes back to the vendor for further checking. Now, whenever they are making any modification or whenever there are any issues which they are facing with this default setup, they might be updating their directory path or they might be updating a few of their file names, and the flow breaks. Then what they can do, the flow while running, if it gets an error, it asks the vendor that I could not find this file, or this source code is not compiling. This is the issue which I'm getting. Are you passing the correct information? They can actually provide yes, no, those kind of details, provide updated paths on in an interactive mode. At the back end, the flow will capture those information and update the configuration.txt file automatically. And then the vendor can rerun it. The flow automatically will rerun, and then it will pass that particular check, which was earlier failing. In the end, once this interaction is all done, then this configuration.txt file is the final updated one. They can share it back with us, and in future this can be used for all the references and checks that this is now the latest and greatest of the setup that we should be using, and the flow will work for all the packages.
Thank you, Preeti. I have one more question coming up. You mentioned about the quality metrics going up from 30% to 95%. So how do we quantify that, or what are the basic quality metrics that is being tracked to say that it's jumped from 30% to 95%?
Okay,
if you can
sure.
please elaborate.
Sure. So there are again mainly 3 to 4 parts to it. One is about the specification. So for example, whenever we are integrating any vendor IP into our tool, we need the framework information. We need the boundary information, all the ports, all the connectivities. Now that is there in the documentation. So if that is not provided and we are unable to create a wrapper around it, which is ready to be integrated in the SOC in our tool, it reports an error. So that is one check in terms of quality, that the specification document needs to be complete. It should have all the required tabs. These documents are mainly in the form of Excel sheets. So it should have all the required tabs, all the required columns and entries that we are looking for, be it for say interfaces or commands or registers, as I mentioned earlier. The second check is on the model compilation, that whether I have all the right information for the model to be compiled. We have seen that vendors, they share everything, but they forgot to share the make file, or they forgot to share a particular define variable hash define, which we had to set up to be able to compile it in our environment. So all that information is again checked by this tool. It checks that I have the right make file. Using all the environment variable, I am able to create that authorization so that this model can be compiled in my environment. If it doesn't happen, it will break, it will fail. The third thing, we also try to do some correlation between the specification document and the source code. So for example, I have all the source code or maybe some binaries from the vendor, and I also have the documentation, but the documentation has mentioned some additional interfaces which were not part of the source code. So again, there was a mismatch that we saw. The specification passed, but the source code failed. Then those kind of correlation we also do, and we make sure that both go hand in hand, and all these things we report to them. So when I said improving all these quality from 30 to 95%, we made sure that all the information in the documentation, in the specification, which we were expecting, are received. The compilation happens well. We have all the setup, all the environment variables. And when we run the IP validator flow, it just runs in one go and everything gets passed. And we are simply ready to integrate in the SOC at our end.
So the number of issues which otherwise you would encounter is significantly reduced. Maybe you're finding a lot of issues with compilation or spec mismatch. So that's where you say that the quality is significantly improved, and you save the time also. Okay.
Yes, that's true. Yeah, good.
Okay. Thank you once again, Preeti.